Welcome to Tami's Max. Today it is 11th standard NCRT. I want to teach the chapter Limits and Derivatives. Starting problems in the exercise and doing it could be done fast. But I would like to spend one class at least in teaching you what is limits. Okay? So this is 11th standard NCRT limits. What is this limit? It's a chapter where children go on asking questions when somebody starts it. Especially if it's 11th standard or it's a 10th standard when they ask you what is 1 by 0, 1 by infinity and all that. Plenty of questions are asked because it's quite curious. You can even take this infinity for research. What are the forms where I can't give answer? 0 power 0, I don't know the answer. 5 power 0 is 1, but 0 power 0 is not 1. Infinity power 0, 1 power infinity, infinity divided by infinity, 0 divided by 0, infinity minus infinity. These are all the forms for which answers I don't know. Then you ask me, ma'am, you say you don't know. What's the use of seeing a channel? Okay. Now, I change my language. Infinity by infinity, 0 plus 0, infinity minus infinity, all this, which I said I don't know. I change my language. I say these are all indeterminate forms. I don't know to determine it. So mathematics terms it as indeterminate forms. Now you feel, yes, Tami's Max channel is delivering some good maths because I am using a very sophisticated language. It's a very sophisticated language, but is as good as saying in a layman's language, I am not aware of all this. This limit deals with such forms. It tries to remove those forms and get an answer to that. These are all important part of calculus, and for an engineer in the future, calculus is a very dominant role. Take an apple, cut it into two. You get quite a good share, don't you? You can eat it. You cut it into 4, you get a small share. You don't get big, but that is also fine. You cut it into 8, you get something. Definitely you get something. You cut it into 16 pieces. Definitely you get something. But I take an apple, I take a knife, I just cut it. What do I get? Can you have a piece in that? Nothing. You can't have a piece in that. So what is happening here, dear students? If it is 1 by 2, I get something. If it is 1 by 4, I get less. If it is 1 by 8, I get still less, and so on. So what happens when the denominator becomes very large, I get nothing at all. It's as good as I'm left with nothing at all. So we say limit 1 by n when n is tending to infinity. N is approaching infinity. When you cut an apple, so many pieces you get. I say infinity. This is equal to 0. There are so many things which we will be discussing. It's not something I can deliver in 5 minutes. What is this infinity? I'll give you some very simple example Suppose there's a person who's getting a salary of 100. He looks at somebody who's getting a salary of 1000. Same person looks at somebody who's getting a salary of a lakh. Same person looks at somebody who's getting a salary of a crore. It's infinity for him. He can't reach it. It's very huge. I can't even use the word very huge. It's something he can't reach. But for a person who is getting a crore, that's nothing for him. That means if you feel you have reached infinity, it ceases to be infinity. It stops to be infinity. Generally speaking, infinity is not included in our domain. What is this video is a little general video, and in the next video I will go for problems from your NCERT textbook. Understand? You have to be very strong in mathematics and you have to be very well versed in the theory part, so that any chapter we can do fast, we can have a good understanding, and we can have an enjoyment, and we can have a very good feeling. That's the reason why I am doing little here and there in this particular video. So what was I talking about? I was talking about limit of 1 by n when n tends to infinity is 0. There is no such thing as infinity in our domain. What is a domain? A domain is that set of function for which a function is defined. A function is real. So when I say something is real, that means there is something which is not real and which is not defined. Square root of negative numbers is not real. When denominator happens to be 0, that is also not counted in the function. For example, you have 1 by x minus 1 as fx. And I ask you, what is domain of x? What did I say? Domain of x is that set of function for which function is defined. Domain, the place where you live. Oh, that is not my domain. Don't you see that? Don't you hear it in day-to-day life? So here the domain will be all x, but x not equal to 1. Because when x equal to 1, it will become 1 by 0. 1 by 0 will be infinity. Now we came for this 1 by n, when n tends to infinity, will be 0. Now, what will be limit of 1 by n when n tends to 0? What will be limit of 1 by n when n tends to 0? See here. I get some value. I get a value more than this. I get a value more than this. Quite plenty I get. Oh. Look at the denominator. So 1 by this. What value will I get, students? What value will I get, viewers? Very large. Very large. Maybe I am not even able to say that. Denominator is not actually 0. Is it 0? No. It's 0.000000001. Whatever it is, it's not 0 at all. So denominator is close to 0. Very close to 0. So you will get a very, very large expression, and that is termed as infinity. So limit n tends to 0. This is tending to 0. 1 by n will be equal to infinity. Now the meaning of tending. Why you say tending? Why you say approaching? We will see right now. The beauty in limit is x is tending to 1. For example, what is going to be the limit of x square minus 1 by x minus 1, x tending to 1. X tending to 1. Why do I say tending? x approaching, x close to. Why can't I say x is equal to 1? I don't use that word. I don't say x is equal to 1. I say x is tending to 1. Now I have to find the limiting value of this. I'll take this 1. Very first thing I will substitute. 1 minus 1, 0. 1 minus 1, 0. Oh God, it takes a form, I don't know. It takes a form indeterminate mathematically. So it's an indeterminate form. Now, how am I to get the answer for this? So all the limit questions will be of this pattern where we try to change it, we try to refine the expression and get an answer to that. This will be limit. X is tending to 1. X square minus 1 can be written as x minus 1 into x plus 1 by x minus 1. X is tending to 1. So I have x here, 1 is here. X can tend to 1, x can approach 1, x can become close to 1 from this side. Where I will say x is always a little less than, little more than 1. A little more than 1, or it can approach from this side where it is a little less than 1. This you say is right limit and this you say is left limit. Only when the right limit and the left limit are equal, we say limit exists. Otherwise, limit will not exist. We will talk about all this. Now, x is tending to 1. The beauty, you have to see the beauty in this. X does not reach 1 at all. If x is going to reach 1, then I will say x is equal to 1. I don't say that. I only say x is tending to 1. So x is not equal to 1. Why is that? I emphasize so much on that. Because x minus 1 will not be 0. X minus 1 will not be 0. So I can cancel these two. If you cancel terms where the term is happening to be 0, then you will get wrong results. We will try it someday. You can prove all wrong results beautifully well. What do you mean by beautifully well in mathematics? As a student, when you are working and it goes like that, farafat, you cancel, you celebrate. You're happy, isn't it? Am I right? Because you feel things are going fine for you. But if you happen to cancel x minus y when x equal to y, it means you're cancelling 0. You will get wrong result. What will be the wrong result? 1 equal to 2, 2 equal to 3, 3 equal to 5. It could be proved beautifully well, yourself equal to myself. All that are wrong results which could be done wonderfully well. We can prove it, we can try it someday. When you cancel x equal to the expression is equal to 0. Fine. The expression is equal to 0. Fine. So now since x minus 1 is not equal to 0, because x is only tending to 1 and x is not equal to 1, I will cancel this. So this will become limit of x is tending to 1 of x plus 1. I substitute 1 here, 1 plus 1 will become 2. It is not necessary that always the limit should take an indeterminate form. For example, what is going to be limit of 5 when x tends to 5? What is going to be limit of 5 when x tends to 5? What is limit of 5 when x tends to 5? It is 5 only. Because there is no x at all there. What is going to be limit of 5 when x tends to infinity? It will be 5 only. There is no x at all. What is going to be limit of 5 when x tends to 0? It will be 5 because it's a constant. Fine. Now, we have many formulas in this. If I simply say this is the formula and carry on, maybe I may not create an interest in you. So, I would like to derive 1 or 2 forms, not more than that. If 1 is registered into you, oh, the other things are like this, you will have a feeling like that. Now we have so many formulas with us And there are so many rhythms in applying the formula. For example, the first formula is limit of sin x by x tending to 0. Put 0. What did I say? You should supply what x is tending to. Supply it. Sin 0 by 0. Sin 0 is 0 by 0. It takes 0 by 0 form, but the answer for this will be 1. How? How is it 1? At least the previous one I was able to factorize and I was able to do it. Let me see how I will work it. Okay? Now look here. Consider applications are more important, but derivations, at least a little here and there, are important as a learner. You're only a learner, isn't it? So you're going to write an exam, you're going to be judged, and you're going to fly in air. That should be your approach, and that should be your success. So for that, we have to make ourselves strong, and we have to make ourselves artists to work. Working artists is a very important part. So limit of sin x by x tending to 0 is 1. Like that, so many things are there. Now let me give you a derivation for just that alone. Consider a circle. You can consider a circle with radius r or radius 1, anything you like. Let me consider a circle with radius 1. Not necessary. You can consider a circle with the radius r also if you want. Let the central angle of this sector be theta radians. This is radians. That is radians, x radians. Let the central angle of this sector be theta radians. Now this is O, this is A, and this is B. Join this. And from the point A, draw a tangent to meet OB produced at D, or anything you like at C, whatever you want. Now, the triangle OAB. I have triangle OAB. OAB. I have sector OAB. I have sector OAB. And I have another triangle OAC. I have another triangle OAC. Another triangle OAC. The triangle OAB. Oh dear viewers, see how lovely it comes. Triangle OAB. The area. I need to say area. Area of the triangle OAB is less than sector OAB. And the sector OAB is less than triangle OAC. And the sector is less than triangle OAC. Fine. Now, I always prefer to give the formulas I use, and I have a small suggestions. When you work this, all the formulas you are using in this, revise it and make yourself a master in that. I say become a master in that. Now if I have a triangle, let me have a triangle. There are so many formulas for area of the triangle, half base into height, and Heron's formula. Like that you have so many things. In that the important formula will be, it is half product of any two sides into sine of this angle. It can be anything. It can be BA into BC into sine of ABC. It can be CA, of course half into. It can be CA into CB into sine of BCA. So area of the triangle is half product of any two sides into sine of the included angle. If you know it, fine. If you don't know it, we learn it. Always we are learners only. Even I am a learner. Everybody is a learner only. So area of this triangle is half 1 into sine theta. Less than. So area of the triangle half product of any two sides into sine of the included angle. Next, what is going to be area of the sector OAB? sector OAB. Now, this is like a small child I am teaching you. If you're very well versed in this, you can just go like that. But always it's better to be kiddish and know from the bottom how to get it. Now, let me have a sector. This area of this full circle, when the central angle is 2 pi, is pi r square. So when it is theta into pi r square by 2 pi. Pi and pi will get cancelled. R square theta by 2. R square theta by 2. Okay, that is measured in radians. So what is area of a sector? It is half r square theta. What is r? Radius. What is theta? Central angle measured in terms of radians. So this sector OAB is half. What is r, dear students? 1. R square 1 into theta. Less than. So this is regarding sector OAB. Now come here. Triangle OAC. Triangle OAC. Triangle OAC is a right angle triangle. Therefore, this angle will be 90. It's a right angle triangle. So area is half OA into AC. Half product of the two arms which contains a right angle. OA is 1. Now, this is theta. This is theta. What is tan theta? Opposite, that is AC. By adjacent, adjacent is 1. So tan theta is AC. So this is half into 1. AC is tan theta. So triangle OAC is half into 1 into tan theta. This is the format. I'm very keen. I got it. I don't need the figure anymore. So I need the board. I will run this. Now, half into sine theta is less than half into theta is less than half into tan theta. Cancel half throughout. Half being a positive number, inequality will not be changed. Sine theta less than theta less than tan theta. Sine theta less than theta less than sine theta by cos theta. Divide throughout by sine theta. Sector angle cannot be more than 180 degrees. Therefore, sine theta will be always positive. Theta will lie only from 0 to 180. First quadrant and second quadrant sine is positive. Divide by sine theta. Sine theta by sine theta 1. Theta by sine theta less than 1 by cos theta. Okay? Put it upside down. So this will come there now. Cos theta less than sine theta by theta, and that is less than 1. Take limit throughout. Take limit throughout when theta tends to 0. Limit cos theta, theta tending to 0, can put here, is less than sine theta by theta, limit theta tending to 0 less than limit 1 theta tending to 0. Is it correct? Fine. Now, what is limit of cos theta? theta when theta tends to 0? 1. Cos theta will be 1 when theta tends to 0. Okay? So this will be 1. Less than limit sin theta by theta, theta tending to 0. What will be limit of 1 when theta tends to 0? What will be limit of 1 when theta tends to 0? Come on, that will be 1 only, no? Just now I told you. What is limit of 5 when theta tends to 0? 5 only. What is limit of 7 when y tends to 0? 7 only. So this will be 1. Oh, now we talk about sandwich theorem. What is sandwich theorem? What is sandwich theorem? Sandwich theorem will be a very beautiful name is given. Very beautiful name is given. Okay? Take a bread slice, take another bread slice and have it like this. Inside you put tomato, it is tomato sandwich. Put potato, potato sandwich. Put egg omelette sandwich. So what is sandwich? There are two things and in between something is called. You have everyday fast food sandwich. So something is caught in between two things. So they say sandwich theorem. See how beautifully they have given you the name. You have to feel it. Mathematics has to be felt. I say how beautiful it is. Only you should feel it. No. How beautiful it is, you only should tell me. So this is lying between two values. It's sandwich. It's a sandwich. It's caught in between. So we say limit of sin theta by theta, theta tends to 0 is 1. Now I'll give you another few minutes and then we will see problems in the next class. Okay. So limit of sin theta by theta, theta tends to 0 is 1. The derivation, I don't say it's going to come for your exam. But you know the derivation, the goodness in doing maths you will have. And mainly Tami's maths channel is to make you feel maths is easy and I'm going to get nothing less than centum in mathematics. Now, there's a rhythm. Maths is always rhythmic. Maths is always musical. What is that rhythm here? Limit. Sin theta by theta, theta tends to 0 is 1. What's the rhythm? There's no rhythm. Your music goes wrong. Your music goes wrong. Talam. Talam is not good. Everything goes wrong. Whatever you have here, the same thing should come here to make the limit 1. What do I mean by that? Suppose if I have limit of sin 2 theta by theta, theta tends to 0. When I supply the limit, without any doubt, it becomes 0 by 0. But the answer for this can't be 1. Why? Whatever, sing a song here. Whatever you have here, same should come here to make the limit 1. Whatever you have here, same thing should come here to make the limit 1. So how will I refine? So this will be limit theta tends to 0. This is sin 2 theta. I will put a 2 here and this theta will be here. But if I want to have the same expression, I should compensate that. Now, limit of the product is product of the limit. So this limit is 1. Whatever I have here, same thing is here. So the limit will be 1. So it is 1 into 2. Answer will be 2 for this. I hope you understand. Okay. So with this, our first video of limit will get over and I will go for problems in the next video. So what are we going to deal with in this topic limits? I don't know. What is that I don't know? Indeterminate forms. A mathematical person will say it is indeterminate, indeterminate, indeterminate. A layman, A layman who doesn't know maths, he will say, I don't know. I don't know. All are one and the same. All are one and the same. So this topic deals with infinity, how when you divide by infinity we get 0, infinity power 0, infinity minus infinity. All these things are going to occur in this. And with this concept, please practice this and come for the next class. We will do lot of questions. Working problems we can do very fast. I'll give you more formulas in the next class, and then we will go for limits. So what is the 3 aspects I have told you in today's class? When I say x tends to 1, x is tending to 1, x is moving towards 1, x is not equal to 1. That's the beauty in limit. Next is, I can have a right limit, I can have a left limit. This right limit and left limit, all that I'll teach you in the next class. I can have a right limit, I can have a left limit. If both the limits are equal in value, only then the limit exists. Otherwise, limit does not exist. Then I have derived a formula for you. A very important formula, starting formula. It's like putting your foot in front and then you're going to run. Limit of sine theta by theta, theta tending to 0 will be 1. And there's a rhythm I told you. There's a rhythm. There's a musical beat. And you should not go wrong in a musical beat. What is that musical beat here? Whatever I have here, I said sing a song. Whatever I have here, same thing should come here for you to have the limit as 1. So all this is registered in your mind. Any problem given in limit, you can get it right without any doubt. So I'll meet you in the next video with more questions and more formulas. Till then, good luck.